Hey, what's up, guys? This is Chung here. So today, let's take a look at another Codeforce problem, yet another task. So basically, Alice and Bob are playing another game, and basically, Alice will take a range of cards, right, from L to right, and then after that, Bob will remove a card. Basically, it will remove the biggest number among that range, right? And then, so in particular, right? So if Alice chooses once with a segment with just one card, then the score after Bob removes the only card will be 0. And our goal is to find the maximum score Alice can take, right? And yeah, and the task is straightforward. We just need to output the max score, right, for Alice after Bob taking out the biggest number within that range. And so we have this kind of n equals to this, right? 10 to the power of 5, that's the number of cards. So here's the second one is a very important one. Basically, the value range for this card for each number only basically within the range of 30. Okay. Yeah, so and here we have some examples here, right? And then for the first examples, that's what we have, right? And the answer is 6. So how did we get 5? How did we get 6? Basically, we will, so the range will be the entire array here, right? So, and if the range is the entire array here, the Bob will definitely remove 10 here. So we have like 5 minus 2, minus 1, 4 left. And so the sum will be 6, right? So that's going to be the final answer. And yeah, and here's another example, right? So we have minus 10, 6, and minus 5. So what's going to be the best approach for this one, right? I think the best, the biggest, the possible number, the biggest number Alice can get is 0. And why is that? Because, so I think one thing we have to be notice that is that the smallest number, right, is 0 for this problem, because the Alice can always take only one numbers, and that will result to 0 score, right? I think because for this case, let's say if all the numbers are negative, or there's only one positive numbers in this case, right? And if we pick more than one numbers, after removing the biggest one, we'll have like we'll have a negative value left. That's why in this case, we'll always basically pick that's just one number, any numbers, so that we can get at least 0 score, right? Okay, so I mean the brute force way to solve this problem is that of course we have to enumerate basically all the combinations, right, of the subarray in the in this array here, and for each of the subarray, we're also gonna basically calculate the biggest number for that subarray, right, so that we can remove that later on. But that's gonna be a n cube like time complexity with 10 to the power of 5. Even n square will t time out, so that n cube will definitely not gonna pass this problem. And how can we solve it, right? I mean, so this one is very similar to like a very basic problem. It's like a Cardan algorithm. Basically, so what the Cardan algorithm is trying to solve is that, given like a array, right? Given like this array, what's going to be the max subarray, right? Basically, the max subarray that can give us the maximum number. If we can somehow convert this problem into that, into that Cardan algorithm, then we can definitely solve this problem, because the time complexity for the Cardan algorithm is O of n, right? So the only difference for this problem is that we need to remove that some number from that array, basically the biggest number from that array, right? And how can we find it? How can we find that biggest number? Since the value range for each number is only within 30s, what we can do here is that we can basically somehow, fix that max number. So what it means is like this. Let's say we fix a number. We fix the max number. Let's say we have some numbers here, right? So let's say from 1 to 30, right? From 1 to 30, and let's fix a number. Let's say that the number we're assuming is, let's say, it's 20 in this case. Okay. So what does it mean? It means that we're assuming, right? We're assuming the biggest number we're trying to remove is 20. Okay. And any number, and then we just go through the entire list here. Any number who is greater than 20, basically we'll set that one to negative, to the smallest number possible. So which means that, let's say we have let's say this number is 25, and this number is 22. So all the other numbers, they're all smaller. They're smaller than 20. Okay. So which means that, since we're assuming, right, so the range, right, so the range we're trying to get from left to right, right, the biggest number within this range is 20. Okay. And anything that's greater than 20 will not be in our range. So which means that, whenever we have, so for this one, that's going to be a valid range, right? And after this one, every time when we see a 25, where it's a number greater than 20, we can mark this one to a smallest number, right? Or in our case, we can always do a current max, set it back to 0, because we know the worst case scenario we can get a 0, right? Basically every time, when we see a number who is greater than this max number here, we can assuming that we're starting a new array, because like I said, because the since we're assuming the biggest number we're trying to remove is 20, and with 25 it means that, our array, the range cannot include this number. So which means that the array has to be starting from here, right? Somewhere to here. Okay. So with this kind of 20, with this kind of the threshold here, basically we're splitting, right? We're splitting this kind of array into few segments. Okay. And then within the each segment, this one is what? This one is actually the Carton algorithm, right? Basically, we're gonna do a biggest values for this within this range here by using a Carton algorithm, and then in the end, we just need to subtract. Basically, we have a summarize, we have sum, right? We subtract with this 20 here, because we're assuming that the 20 will be our biggest value here, right? But then someone may ask, right? What if there's no 20 in this case? What if what if for these four numbers the biggest is 10, right? But then it's fine, right? It will not affect our final result. So the reason being is that since we're going to try all the possible numbers from 1 to 30, even though there's no 20 in this case, but we will try 10 eventually, right? So, and when we try 10, we'll get the correct answer for this range, right? And that's that. And another thing is that, why we don't need to worry about minus 30 to 0, right? Because, if our biggest number is either 0 or smaller than 0, it means that, it basically we're saying that, there's no positive number in this array here. So which means that in that case, we should only pick one number, right? Because, that's because by picking only one number, it can give us 0. Otherwise, we'll definitely get a negative number, negative final answer. Okay, right. Yeah, I believe that's the basic idea here. Basically, so we loop through the from 1 to 30, and we're assuming that's going to be the biggest number we're trying to remove, right? And then with this one number here, basically we're somehow splitting this array into different segments, right? And then every time we see like a number who is greater than the current threshold here, we start with a new array. Yeah, and within that array here, we use the Carton algorithm to calculate that. Cool. I think we can start coding here. Yeah. So we have this one here, and let's see what else. Okay, cool. I think we have already defined everything here. So I mean, so first, we read the n here, and then we also read the each number, right, from I to 0, I smaller than n, and I plus plus, right, and then CIN AI. Cool. So, and then for the final answer, right, we're assuming, so now here I set 0 because the worst case scenario is 0, like I said, right? And then for int I, let's actually for I from 1 to 30, right? Equals smaller than 30, and I plus plus, and then for the inner loop, right? So we have an inner just like the Cardan algorithm. So Carton max is going to be 0, right? And then for int j equals to 0, j smaller than n, right? J plus plus, right? Because we're gonna loop through the entire array for each of the the max values, right? So if the a and j, right, is greater than I, right, it means that okay, so that's gonna be the end, right? So which means that we need to start a new range. So which means that we have to reset the thing back to 0, right? And then we'll just simply continue. Right, so this one is as if we're like basically set this aj equals to the infinite small number here, but it doesn't. But we don't have to do it because like I said, we only in that case it means that we're gonna start with a new like a range here, right? Otherwise, the current max, right, is gonna be what? Gonna be aj, right, plus what? Plus max of the previous one, the current max dot 0, right? And basically, this is the template of the Cardan, right? Cardan algorithm. So we use the current number plus the previously accumulated result, and then we do a max with 0. That's how we get the maximum, right? And then for this problem, we need to add one more step, right? Because we have to do a current max minus I, right? That's how we update the final answer, because for this I here, we're assuming that we will be in the end we'll subtract this I from the final answer. That's why for each of the step here, we will basically subtract this I when we update this answer here. Yeah, I think that's it, right? So, and after this one, we simply just do a output of the answer here. Yep. So that's it. Okay. If I run the code here, so let's try a few examples here. So this one we're expecting 6, right? Yeah, so we have 6. And then how about this one? So this one we're expecting 10. Okay. Yeah, 10 is also correct. So last one is this one. So for this one we're expecting 0, right? Yep. So it's also correct. So now as you guys can see, right? So the time complexity for this one actually is the 30 times n, right? Which is equals to O of n. Cool. And yeah, I think that's pretty much it is for this problem. It's a very interesting like a variation of our Cardan algorithm. With this kind of like assumption that we can fix this kind of the max values the Bob will remove. You know, like I said, after that, we can just convert this algorithm. We can convert this array into several sub arrays here, right? And then we can apply the uh, the Cardan algorithm on top of each of the array here. And then in the end, we just get our final answer. Cool. I think that's it for this problem. Yeah, hope you guys like it. And thank you for watching the video, guys, and stay tuned. See you guys soon. Bye bye.